So let us further our discussion. In the last class, we were discussing about waves, and we were talking about this progressive wave, the equation. So the equation that we are going to learn today, which is there in your syllabus, is y sine of kx minus omega t plus phi. This is a equation of the progressive wave which you are going to study. Check if this wave is in the format of y of a function of x comma t. It is a function of x comma t. We were discussing that it should be in the format of f of ax plus bt. What is this? This is basically function of x comma t, two variables x and t here, and y is the displacement. So this equation is in this format. So it is the equation of a progressive wave. Okay, so here we have got some terms. This is a sine function. This is a sine function, trigonometric function. Okay, now this sine function or a cosine function is a periodic function. When you talk about sine or cosine functions, quite frequently you will be coming across these two. They are periodic functions. Periodic functions. What do I mean by periodic? They repeat after some time. They repeat after some time. Okay. Now everything that is there inside this sign, under this bracket, this whole stuff is called argument. Not the kind of argument people have between them. It is called argument. Alright. So this term is called amplitude. By this time you know what is amplitude. Suppose you have got a wave and you got another wave whose amplitude is more. This amplitude is more. Amplitude is the maximum distance from the main position. This fellow's amplitude is only this much, and here this is this much. So whose amplitude is more? This one. Okay. Amplitude, basically all particles are getting displaced from their mean position. Okay. Now you have got this k. Now k is called angular wave number. Okay. Now first there are two terms here. You come across one wave number. Let us understand what is a wave number. Suppose I take a 1 meter distance. I take a 1 meter distance, which is also called a unit distance, and I am studying a particular wave. Now that wave is like this. Okay. So in the previous class we have studied that from this point to this point it is called one cycle. Alright. From crest to crest is called lambda wavelength. So what is wave number means? A number which tells you in 1 meter distance how many waves are present. How many waves are present. Okay. So this gives you an idea about wave number. So what is the unit here means? It is meter inverse. Okay. How do you write here wave number? Suppose some mu bar is equal to 1 upon lambda. 1 has got no unit. Lambda is measured. Lambda means what? Wavelength, no? So 1 by meter. So meter inverse. So this is about wave number. Okay. Now when we talk about angular wave number, so angular wave number is given in radians per meter. Angular number, wave number, it is measured in radians per meter. Okay, this is in 1 meter distance how many waves are there. So in 2 pi radians how many waves are there. So what is one cycle? One cycle corresponds to 2 pi radians. So it is given by 2 pi divided by lambda. And what are the units? 2 pi, this is in radians, and divided by meter. Okay, so this is about angular wave number. Omega, it is the angular frequency. It is the angular frequency. Omega is given by, see, what is omega? Omega is angular speed, right? So what is omega? We have seen in oscillation also. Omega is 2 pi divided by t. 1 upon t is frequency, so it is 2 pi nu. All right. You look here, 1 upon t, you are calling it as frequency. Okay. So that frequency is related to time. Now this 1 upon lambda, it is looking quite similar to that. Now this is also called spatial frequency. Spatial frequency. Okay. You are getting here 2 pi into 1 upon t. 1 upon t is frequency. Now this frequency is with reference to time. If it is with reference to distance, it is called spatial frequency. So omega we have seen. Now the one very important concept, this is called phase constant. We need to understand what is a phase constant. Let us try to see with a simple example. So some person is there and this is his home. Now he wants to go to some, let us say, temple. Okay, he started at 10 o'clock. Okay, and he started here and he traveled up to this point. Okay, take another situation where between home and temple there is some stationery shop. Okay, I'm talking about the same person. You can take some other person also. Now this fellow at time 10 o'clock he was here, or on some other day, let us say this fellow A was now here. Now he started here. It is in the same line, let us say it is somewhere here, and he started here and he went to the temple. Now what happened? If you take home, being at home as the reference, he should have started from here. But basically in case 2, he started from here. That means there is a gap here, isn't it? I am trying to give an analogous situation. So this gap, what you are saying, originally he should have started here, but there is a gap now. This is called your phase constant. Look at our equation. Y is equal to A sine of kx minus omega t plus phi. This is the equation. For the time being, you call this equation as kx minus omega t. Don't put this phi. Just put like this. I will take the situation when time is equal to 0. At time is equal to 0, at 10 o'clock, where was this sine function? See, this is a constant. Okay. Now this wave is dependent upon this term. This anytime is constant. Amplitude is a constant. It is not changing. What is changing? This is changing. Okay. Here also we have simplified. There are two variables. Now we have put one variable t is equal to 0 we are talking about. So purely it will convert into y is equal to sine of kx, isn't it? Because at t is equal to 0, you have to put t is equal to 0. This equation converts into this equation. What is this equation? It is pure sine function. So sine function, if you draw the graph, sine 0 is 0, sine pi by 2 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, sine 2 pi is 0. You will have a graph something like this. Okay, if I write the values also here, So this corresponds to pi by 2, this corresponds to pi, this corresponds to 3 pi by 2, and this corresponds to 2 pi. Now after this what will happen? The same pattern will repeat. Because the same pattern is getting repeated, we are calling this as a periodic function. Okay, from here one cycle, then second cycle, then third cycle, then fourth cycle, and so on and so forth. Okay, at t is equal to 0, what is the value of y? Y is equal to 0. That means at initial time it was starting over here. Okay, now suppose the same equation was something like this: y of sine a sine kx plus pi by 2. Suppose it was like this. So here what is happening? At t is equal to 0, what are you getting? You are getting a sine kx plus pi by 2. Okay, so this value corresponds to x is equal to 0. You take x is equal to 0 also. Okay, so what is this point? This point is x is equal to 0, isn't it? All these points have some x values. If you take some point here, you take some point here, these have got some particular x values. X also we will take 0. Then what you are getting? You are getting y is equal to a sine pi by 2. Okay, but sine pi by 2 is 1. So y is equal to a. So what is your a? This distance is your a, amplitude. So at t is equal to 0, actually the wave is starting from this point. It is not starting from this point like in the previous case. So there is a gap. There is a gap. If you carefully observe, let us say this is my x-axis and this is my y-axis. You just shift this axis to this point, y dash, y double dash. Is it looking like the axis, the y-axis got shifted by this much amount? So that is the initial phase. Okay, every time it is not necessary that the wave will start from this point only. It can start from this other point also. When it starts from this point, how you are going to write that equation? How you are going to draw that? It will be drawn something like this. Look here. It will be like this. So in this situation, what is happening? Compare this with this equation. The original case, it was like this, right? It was like this. So here there is some phase. Initially it was not at 0. Okay, so initially some phase is there. So in that equation what you are writing, this is the general form of writing any wave equation. Suppose phi becomes equal to 0, it means the wave is like this. Otherwise the wave is not like this, it is in some other way. It is like this. Okay, so that means the wave did not start at the origin. It definitely started from some other point. In the place of sine there can be a cosine function also, but the definition of phase remains same only. The concept of phase remains same. Now you have another concept called phase difference. Phase difference. It is denoted by delta phi. Basically delta phi means phi 1 minus phi 2. This corresponds to wave 1 and this corresponds to wave 2. Suppose phase difference, when you talk about two waves. You cannot talk about the same wave, you know. So let us say there is a wave 1, it has got some phase, and wave 2, it has got some phase. So what is the phase difference means? Phi 1 minus phi 2. Now how to calculate this? If you want to understand this with a example, something related with life, you see here I am trying to give some examples, you know, which you are able to connect with. Suppose there is a fellow, there are two fellows, two people standing near a pond. Okay? There is a pond. This is all a pond. Suppose exactly at 10 o'clock, this fellow threw a stone, and this fellow also threw a stone exactly at the same point. So a wave is created. Look here, both are throwing a stone and creating a wave exactly at the same time. There is no time gap. So you will say that both are in phase. Both are in phase. Okay? Suppose this fellow threw the stone at 10 o'clock and this fellow threw the stone at 10:01. There is a time gap also now. So they are not in phase. See, when you throw the stone, some wave is created here. This fellow threw the stone, some wave is created. Both two waves are not in phase. They are not in phase first of all. So, there must be some phase difference. There must be some phase difference. So, let us say you have taken a wave, okay? So, from here to here, I will call this as wave 1, and from here to here, I will call this as wave 2. So, this corresponds to wave 1, and this corresponds to wave 2. I'll put some names here. This is A, this is A dash, this is B, so this is B dash, this is C, so this is C dash. Can I say that A and A dash is similar? B and B dash is similar? C and C dash is similar. Okay. So, what is the distance between C to C dash? The distance is your wavelength only. Okay. Now from here, from A to A dash, you are calling it as one cycle, which corresponds to 2 pi radians. Okay. When this wave is starting at this point and it is going up, it is also going up in a similar way. So can I say that the difference between these two, if I talk in terms of phases, see, talking in terms of phases means you have to talk in terms of angles. So when A is going up, A dash is also going up. When C is going down, C dash is going down. Alright. From this point, from C to B, it is going down. The pattern is same. So in one cycle, the difference of phase is 2 pi radians. Okay. You imagine this as one wave and this as another wave. You can draw this wave another way here also, like this. If you are not comfortable here, you draw here. This portion, you draw it here and compare and see. This is going up, this is going up, this is going down, this is going down. Absolutely same. So one cycle corresponds to 2 pi radians, and when the difference between two waves, the phase difference is 2 pi, the pattern is absolutely repeated for a sine curve, and so on for the cosine curve also. Okay, so the 2 pi radians, what you're talking about, okay, these two waves are said to be in phase. There's a term called both the waves, wave 1 and 2. 1 and 2 are in phase. They are in phase. Okay. So this is one concept. Now see, I am taking A and A dash, but I can take some other point also. I can take A and I can compare with some other point. Then how to find the phase difference? So for that, you see this simple calculation. See, when you're talking about one cycle, when it is 2 pi radians, okay, what was the distance? It was lambda, isn't it? So from here to here it is one cycle, from here to here it is one cycle. What is the gap? Lambda. Okay. Now suppose there are two waves, and between the two waves you're trying to calculate the phase difference, and phase difference is expressed in terms of angles. Let us say the phase difference is delta phi. The phase difference between two waves is delta phi. See, when the phase difference is 2 pi radians, the distance is lambda. When the phase difference is delta phi, let us say the distance was delta x. Distance was delta x. So we have to find out what is delta phi. Cross multiply. Delta phi into lambda is equal to delta x into 2 pi, or delta phi is equal to delta 2 pi by lambda, 2 pi by lambda into delta x. Okay, this is the equation to find the phase difference between any two waves. Like in the previous example, if I take the point A and I take the point B, look here, from here to here it is lambda. Since the wave is absolutely symmetrical, so A to B will be the half distance. This will be lambda by 2. Okay. Suppose if I tell you that lambda by 2 distance I am giving you, what is the phase difference? How will you find out? You put it in this equation. Delta phi is equal to 2 pi by lambda. What is delta x? Delta x is a measure of distance. So how much distance we have taken? Lambda by 2. So lambda by 2 you put here. Are you getting pi? You are getting pi. So when you took A and B, how much phase difference you got? You got pi. A to A dash is 2 pi, A to B is pi. If you try to plot this, let us see what happens. If you try to plot this, let us see what happens. Look here. The first wave is as it is. Okay. Now, because I am plotting separately, I have to take this as the starting point. So starting point, if I take, it is like this, isn't it? This is my wave 2. This is my wave 1. If the wave is starting at B location. Now carefully observe here. This wave, ये उसका right उल्टा है. This is right ulta of wave 1. 2 is ulta, opposite of 1. This fellow going up, this fellow going down. This fellow reaching here, this fellow reaching here. This fellow going down, this fellow going up. So they are exactly opposite. They are exactly opposite. कि मान लो कि कोई गाड़ी ऐसे जा रही है, उसको ठीक मैंने पीछे घुमा दिया, तो तुमने क्या लिया? 180 degree turn. So the phase difference between these two is 180 degree turn. ठीक है? It's an absolutely 180 degree turn. Okay? So these two types of waves, there is a term called they are out of phase. इस term को समझ लो. They are out of phase. So when you say two waves are in phase, the delta phi should be 2 pi radians. When they are out of phase, the delta phi value is pi radians. It is like एक गाड़ी गया और यू टर्न ठीक वहीं पर यू टर्न मार के वापस आ गया. So it is called out of phase. So this term you should be very convenient with. So I think we have discussed that equation per se, and yeah, all the points related to that is covered.